Hi, today we're going to be looking at curves of best fit because some or not all real world scenarios will produce a linear relationship. So we'll take a look at this data. We're going to be looking at the population of thousands of bacteria in a Petri dish. And so I've gone ahead and I've put the scale on the grid here. Now this grid isn't really the best that I've drawn because we see that we're going from 0 hours up to 11 hours, but then if you will examine more carefully down here, I'm going to be asking for a prediction, what's the approximate population after 12 hours. And the reason why I said the grid isn't that great is because to space out the points well, I used 50 units or 50,000 bacteria per space vertically. And at the 11-hour mark, there's 980,000 bacteria, and that's down around here. That would be about 980,000 here. And if we take a look at the difference, we're seeing the first differences here between the 0th hour, or the beginning of the observation period, to the first hour. There's a difference of 3,000 bacteria. Then between 1 and 2 hours, there's a difference of 5,000 bacteria, and then 9,000, and then 16,000, and then this would be, I believe, 29,000, then 45,000, etc. So we see right off the bat that because of the differences, the finite differences, that because that's not constant, we know that this is not a linear relationship. When we get up to the upper part of this, the difference between the 9th and 10th hour is 210,000 bacteria. The difference between the 10th and 11th hour, I believe that's 390,000. Maybe here between the 8th and 9th hour, we've got 130,000 difference. So it's going up by 80, then going up by 180. Then who knows, maybe it'll go up by 250 maybe. No, actually that'd be a little bit more, sorry. The increase is going up by 180, so it's increasing even more than the increase. So I would say that this, who knows, might be, let's say 540, for example, like I'm just guessing. And so maybe for the 12th hour, we might get up to 1,520,000 or 1,520,000 bacteria. So we see that the increase is obviously increasing as we go. That's kind of what makes it exponential. And at the 12th hour, well, we need to be up to 1,520. Well, the scale only goes up to 1,100. So I would need to add a little extra onto this vertical scale. So I'll take this that I prepared before and just plop this on the top here. We need to extend the scale more than we have, of course. And anyway, so I'm going to plot the points, and that was just a little bit of preemptive adjustment to the vertical scale. And so the first few are going to be difficult to plot because of just the scale here from the base up to the first in the first space here is 50,000 bacteria, whereas at the 0th hour we've only got 3,000 bacteria. So I have to sort of judge where 3,000 would be in here from 0 to 50,000. So I'm just going to have to plot this as close to the horizontal axis as possible. After 1 hour, it's 6,000, so it's going to go up a little bit, but not really appreciably. Then after 2 hours, it's 11,000, so you can see that would be about 1/5 of the way along this space here. So maybe here-ish. We can see it kind of rising a little bit now. 3 hours would be 20,000, so that's just a little bit shy of halfway up this box. 4 hours is 36,000, so just a tiny bit above halfway, I suppose. 6 hours is 65,000. Sorry, that's 5 hours, 65,000. So it's going to be in the second box now, but just shy of the halfway mark of that second box. 6 hours would be 110,000, so we're just over the 100,000 mark. Now we're starting to really see that curve form now. The first few points might have looked more like a line, but we're really starting to see that curve. 7 hours would be 190,000, so that would be up around here. 8 hours is 380,000, so that's going to be just shy, just above halfway up that box just before 400, or between 350,000 and 400,000. At 9 hours, we're at, oh, sorry, so that should be 250,000 for the 8 hours. And the 9 hour mark should be 380,000. I skipped one there, I'm sorry about that. And then 10 hours would be 590,000, just short of 600,000. And then for 11 hours, we're looking at 980,000, which would be around here-ish. In a way, okay. So one of the questions here is, which is the better approximation for the data, a line or a curve? Well, we could draw a line and we could see what would result here. So if I take this purple here, and suppose I say, well, down here looks pretty flat, so I can maybe draw a line like that. That kind of gives a bit of a trend at the beginning, but it doesn't do the rest of it here. I could draw maybe a line like this to kind of to look at a bit of the trend as it's really increasing, but that still doesn't give it, because we've gotten 2 trends, but we should only be having 1 trend. So the best way to really do this is by hand and by eye kind of thing. I don't really have a steady hand, so this is going to be really difficult for me. But you need to sort of try to approximate the curve the best you can. You can try to go through as many points as you can. You can maybe turn your paper on the side or whatever, and just try to get the curve to go through the points the best you can. I'm off a little bit there. But that's sort of the idea. You just want to follow the trend of the data the best you can, and then extend it. And the extension part is going to be the hardest part for me, I think. And I just keep extending it. It's getting fairly vertical now, and extend it as high as I can. And the reason why I want to extend it further is because I know for part B here, I want to look for the approximate population of the bacteria after 12 hours. Well, let's look at this answer here first before we continue. With the better approximation, a line or a curve, well, you can sort of see that the curve does follow the trend of the data better than any one line. So I would say a curve. A curve will fit the line, or fit the data closer. I try not to say the word better, because better, there's all kinds of different adjectives that you can use for better. It's a better fit, it's better height, better, I don't know. So I would just say that the curve would fit the data better, or sorry, closer. Here I go again. And so now, what's the approximate population of the bacteria after 12 hours? Well, after 12 hours, well, 12 is right here. That's the 12-hour mark right there. So what I'm going to do is I'm going to bring this over to extend this 12-hour marking, so I can have a bit better view of this. And I would say that it would be around here-ish. Okay, and then if I'm going to draw, I should draw a horizontal line using a ruler, so I don't freehand it and mess it up. So from there, I'm just going to go across horizontal. So I would say, as a rough estimate, It's between 1.5 million and 1.6 million. So it's around halfway, probably a little bit less than halfway. So let's say that's 1,540,000. So I'll just say 1,540,000 bacteria. Okay, so again, just an estimate, because that's all we can really do at that point. And that's basically how we would do curves of best fit. Just sort of plot the points and draw the curve the best you can through as many points as possible. All right, so that is that. And here's a little bit of work for you to keep yourselves busy. Thanks for watching, and we'll see you in the next video.